Welcome back. As we get ready for the next talk, be sure to share your experiences with Spring One on social media. Hashtag it, hashtag Spring One. Now I'm happy to introduce the next talk, Writing Unadulterated Services with Kotlin and Coroutine. Here is Zohaib Sibte Hassan.
Hello, everyone. My name is Zohaib. Welcome to the session of Writing Unadulterated Services with Kotlin and Coroutines. A little bit of introduction about myself. Right now, I'm working at DoorDash. Here's my Twitter handle for those who want to kind of follow some chaotic and tech investigations that I do all the time. So a little bit of introduction about DoorDash. DoorDash is a delivery platform, and I hope most of you have used it. For those who have not, we started off with a food delivery, and the idea is that you place your order online through the app, and we have dashers who are going to get your order delivered to you. And of course, if it's a food order, in that case, we have to make sure that the order gets delivered to the merchant as well. And by the time dasher arrives at the merchant, the order is ready, prepared, and good to go. The reason to kind of call out this whole thing is because I want you to kind of imagine the complexity and the timing on the critical pieces that are involved in making all of this happen. It might seem simple on the surface, but under the hood, it's really difficult. One of the things we have to do, we used to be a Python 2 shop with Django. And one of the things we had to do while we were migrating out from a huge monolith into these microservices was to evaluate different technologies and look at which one should be top. So most of the talk that you're going to listen to today are the lessons and the things that we've derived out of our battle-tested, experiences. So with that, let's get started. So as a company, when you're trying to pick a stack, the first thing I would love to say is that it's hard. It's hard job to look into the future, and it would usually depend a lot on your context. Sometimes particular things would make sense that won't make sense in another context. So like picking a functional language or picking a more object-oriented language. These are the debates that would totally depend on the context. The key factors that we kind of looked into while picking stacks was solid community in the ecosystem, true multi-threading, no global JILs or global interpreted locks, and I would come to it in later slides as well, why I'm saying this, or bottlenecks. A true async IO and multi-reactor pattern, that like we wanted to utilize our cores to their max and squeeze out as much juice as possible from the hardware as we can. So these were just a couple of things, like just the highlights. There were, of course, more developer productivity, the whole tooling around it, the whole the ecosystem built around the whole thing. But these were the key aspects that we were looking into. So today we will focus on why we picked JVM in this particular context, then why Reactor and Spring, and then why Kotlin and Coroutines. So why JVM? I think this is the most obvious thing. I don't think I have to I would stay longer on this slide. It's battle tested, plethora of options in terms of the type of JVMs that you can get out there, truly multi-threaded, solid JIT and garbage collection. Like there's so many garbage collectors you can select from, and ZGC and Shenandoah are just starting there with low latency garbage collection. Strong community and ecosystem, and I can keep going on and on about JVM itself. As I mentioned before, like true multi-threading, I call it out as a bullet point. I just want to show you an example what's it like to kind of stick into these interpreted languages where they're not truly multi-threaded. Here's one of the recent posts from Clubhouse where they were trying to squeeze maximum out of their CPUs, and they were having a hard time. It kind of goes through how they kind of run multiple processes. I know they're in Node.js, PHP, all of these kind of run on the same philosophy, one process. And people do this run multiple processes in order to use multiple cores. But even with that, there are problems. But you can go check it out. It's a good post if you work in Django land, and if you're in the middle of thinking about, hey, if you should be using Django or Python versus a truly multi-threaded ecosystem. But this kind of goes to show the problem in these ecosystems that people are still going through. And this is like maybe a month old post or something, but not too long ago. So why Reactor and Spring? Well, it's battle tested, widely adopted. I mean, anybody can vouch for that. It's probably the most widely adopted framework in anybody in Java ecosystem. Strong community, tooling and support. Like you find plethora of libraries and ton of supports across like internet for any problems that you would see. The last point is the most interesting one, which I was kind of taken up by surprise when I started working on it. So using the reactor, Spring Webflux, and Spring Webflux can actually give you an async IO and an event-driven support as well. This is where I think it becomes a really interesting tool in the belt for anybody who's using such a widely adopted framework. So what about the reactor pattern and all that? Why am I kind of honing in on this? I think it has been proven time and again, and I think it was really popularized. The whole thing was really popularized, or async events, or async event-driven programming. Like, there are multiple names, but this whole thing was actually really popularized, I would say, with Node.js, where it just kind of skyrocketed. So reactor pattern is important for us because we want to utilize maximum amount of CPU while keeping everything unblocked and keep handling the requests. And you'll see as I go forward how this ties into this whole thing. So given that we want to use reactor pattern, if we are looking at the JVM ecosystem, what are the options? And I would warn you, there is some fragmentation in this whole ecosystem. This is where I would rant about it a lot. But this is the sad truth, I would say, because I believe in early days, or in the beginning, the whole async pattern and the whole ecosystem around it, the first class support was not settled really well. So each of the individual libraries spinning up, they created their own thing. So let's kind of go take it one by one, what I mean by this. So let's start with the fact that I want to do asynchronous IO. So what are the options for doing asynchronous IO? So, well, there are a bunch of frameworks out there that would let you do this. Java has its own NIO. Then there's the Netty project, which is probably the most famous one. Then we have Pachimina and Project Grizzly. And like, you can go and look at them, and each one of these projects, each one of the open source projects have their own pros and cons. Netty is the most famous one because I believe it's really well supported. The ecosystem around it, it's really strong, and it has really matured over time. About Grizzly and Mina, I'm not really sure how mature, how well they are. The fact that not a lot of people are talking about it kind of tells me like probably there's not a big ecosystem around the whole thing. So once you have the async IO, then you have to build abstractions on top of this async IO, right? So what are the right methods to build these abstractions? And when I'm saying abstractions, you spin off something and you need some kind of abstraction to kind of wait on it, or kind of say, oh, when then that thing is done, let me know, because this whole thing is event driven rather than polling you're being notified. So what kind of abstractions we have available? As a brief history of abstractions, that like from abstractions, I'm taking words like future, promises, monos, flux. There's a whole dictionary of these, a completion stage, and like I can keep going on and on. But I think if you go all the way into the history, the first traces of promise you would see in Algo way back in 1961. But I think where it really took off, or where people started paying attention to it, it was Python twisted with its deferred. Here's another different name. And similarly, when then JS came in and popularized the whole concept of async IO, and then we got promises, and the JS kind of keep evolving into it. So even in the framework terms, there's fragmentation here as well. Like so Java has its own thing: completion stage, future, stream, popularized in Java 5 onwards, but people felt like it's not doing exactly what I want. I want these additional abstractions on top of it. And the fact that the types sometimes were sealed, or people were not happy with the interfaces, or there were more inventions. Reactor, the Spring de facto, is right on the top, right? And I feel like it's probably among the most supported ones. Probably here, I think there are two more famous ones: Reactor and RxJava. RxJava is the next one, but RxJava, even within RxJava, if you're within RX2 and RX3, you would see there is a huge fragmentation. Vertex is another one. They have their own implementation. Mutiny is this new kid on the block with the same thing. Quasar, like it inspired itself from Erlang and Go, and possibly the project is that I don't see it active anymore. Similarly, we have Eka and Google. I don't know why they did it, but Guava has its own listenable feature because it's Google, and there are more. Like it's frustrating when you start looking into it, but there are more. But don't worry, there is Reactor Manifesto now. And way back in 2014, people noticed like everybody is doing the same thing, and they kind of looked into the whole libraries that were existing, and they were like, oh, let's build a one common interface that everybody agrees on. And the Reactor Manifesto is there. RxJava, most of the common famous libraries today are kind of implementing it today. So that kind of gives you kind of a consolidation on like, yeah, that everything is consolidated under this Reactor Manifesto, and same interfaces are defined. But this leads to the problem of callback hell. If you're from JS World, or if you have ever worked on the future promises Reactor, you would know how hard it is to reason and debug this code, and you will see it in the coming slides. What I mean by this. So what can we do? So later on, everybody asked this question. Once they saw the callback hell, they were like, what can we do? So just to give you context, when I was coming into Java, I was coming in from C# world. And in C# world, they already solved the whole thing with task processing libraries and with async await. And that's where I'm going to go next. So async await is a pattern that going forward that was introduced to kind of make this callback hellish code look sequential, clean. C# 2011, Python 3.5 did it. Later on, most of the languages adopted it. So does Java has an async await? No, not so far. But of course, there are alternatives to it. But again, it won't let you write sequential code. But future is not bleak, I would say. There's still hope. Project Loom, return to virtual threads are coming because Java 1.1 or 1.2, I cannot recall. One of them used to be on green threads. They were not like physical threads that were blocking, but now they're saying, oh, let's go back to the virtual threads where it would automatically do everything for you under the hood. So why Kotlin and coroutines? Warning, we're entering the code territory. It's a brief overview, but we're entering the code territory now. So testbed setup. Let me quickly show you the end result of what you're going to see, and we'll work backwards from there. So here I have a running Kotlin project where I wrote a simple piece of code where all we're doing is given an IP, we resolve the IP from an external service, and as practice or simplicity, what I've done is I've kept all the abstracts really simple, concepts really simple, but then I've added a database layer and a Redis cache layer. So you can see suspend. Pay attention to these functions. Like, look at this. It absolutely looks like a sequential code where I say, oh, with suspend function, locate, and I'm getting the IP. With context, I launch it on a default dispatcher. I'll come back to this. I say repo.find IP. And if I go inside my repo, you can see it looks pretty sequential from cache in Redis cache and database cache, and then call the service. And if I go inside the call to service, you would see all I do is I have a web client here with the base URL. And all I do is I prepare the request, map it to the geoinfo entity, and then I say await single. I get the response. And over here, I want you to pay some attention because all I'm doing is this whole piece of code is asynchronous, but it looks so sequential that it might cheat your brain. If it's not successful, I throw an exception, I log the body, I make a copy of the object with the IP assigned to it. Otherwise, I throw the response exception. It looks extremely simple, right? And just to show you, it actually works. So I am making the call. So the network call is expensive, but now that I've resolved it, if I do it again, I'll see that the response comes back immediately because it's cached. And just to kind of show you that it's actually populating the database as well, you can see right here is where I made the call, right? So the end effect is going to be pretty sequential or regular code that you're used to writing. So let's go back and see what happens. So let's start with defining the basic geoinfo object. How would it look in Java, right? And here I've created a basic POJO object where IP, city, country, lat, long, the same fields that you saw with the ORM mapping in here for simplicity. What I want you to do is pay attention to this. Like you do this group all the time. And now what I'm going to show you is then there are more, like even there are conversations and debates around here, which libraries you use or all that. Over here, I'm using Lombok, pretty standard stuff. Here is the Kotlin version of the same class. It's a data class, lets me make copies. The important pieces to note here is the immutability built in. Val and var are two different things, and all the variables over here are val, which enforces the fact that I cannot change them once I've assigned the values. And you can do the similar thing with the annotations, but being this a first-class citizen, you won't have to negotiate with anyone on saying, hey, you use the Lombok again, or like, oh, okay, so you have the getters and setters again. But you would get into trouble for nullability, for example. Non-null, there are a million different libraries to do non-null annotations. Here's the first-class citizen for something being nullable and non-nullable. That's the difference. But that's a Kotlin feature, right? Let's look at the same call that I did in Kotlin a minute ago, where you saw a linear piece of code, and I'm trying to do the same call with reactor over here. I create a mono defer. Then I have an HTTP client, which is again a web client. I create a URI, I retrieve it. I say publish on this and flat map and then in the body, you have this bunch of code to kind of do the whole processing, the post-processing of the response. The places I want you to pay attention to are these underlines, like publish on. If I don't do it, and if I do anything intensive, I might end up running my code on the async IO thread pool. Similarly, the throw, you have to kind of rewire your brain on these things. Now, instead of throw, you're doing mono error here. And like, it's okay, but it's still kind of a rewiring. And here's the corresponding Kotlin version of that, right? So you can kind of compare it. It literally like looks like a linear thing where I'm just saying cat retrieve to map to plus await single, and I have the response object, and I'm writing my regular ifs and throws. The important thing to note here is this await single, because this glue code that is converting that mono into something that Kotlin suspend function understands, or Kotlin can suspend on, is given by the coroutine library itself. But that's the only thing. The await single is kind of giving you the fact that, hey, I'm awaiting on the mono here. Once the results are back, then continue on. So let's do a database to save the calls. We did the call to kind of make the network call and fetch the response. What I want to do is something like this: database cached with IP and callback. And callback, I'm saying call service with IP, right? So where can I get reactive database? You're in luck. R2DBC for now has reactive database. Here is a typical reactor reactive repository. I have an upsert method here. This is for Postgres dialect. So here's cache database. I see IP, then the supplier for a mono that's going to fetch. So first I say find by database, this IB, switch if empty. So if I don't find the results or if it errors out, I want to call the fetch, I get the results, and then I flat map it to update database so that I can update my database with the response. Then in find database, pretty simple as well, but you can kind of see the nesting happening now, right? If I were to put this whole thing in a single piece of function, you would see it would be really hard to reason, but I'm trying to break it down. It's a good practice anyway. So I do database find repo by ID, do a next, I do a log, and in case of error, I resume with empty mono so that even if database fails, I emit out an empty mono. And then update database is pretty simple. I just take the defer and I publish on parallel. The places I want you to focus on is I'm constantly doing this publish on, and you might be thinking, why am I doing this thing? Well, if you don't do this, you might end up on a situation like this where you're running your code on a TCP and IO thread, the reactor core threads. And that's why you would be paying attention to these minute details all the time to kind of think about, hey, what if this is wrong? What if that's wrong? What if you missed this piece? Over here, I've done the whole database cached for the whole method here. So let's have one look at this whole method again before we switch into Kotlin version. You have to remember switch if empty in case there is an error. I'm doing all this logic in the middle to kind of compensate for that. And on error, I'm emitting out an empty response just to make sure that even if database fails, I don't do anything weird. So let's move on to the, this was a reactive CRUD repository. This is a same reactive CRUD repository in Kotlin. You can kind of see the method with mono in there. Here's a database cache method, the worst way I can implement it. And you can see the same try catch on the top with optional empty. I'm doing find by ID await single or null to make it optional. Then if it's present, I do a get. Otherwise, I call the method that's also a suspend method. And then I do the upsert handling the errors. Looks pretty standard, right? I'm doing try catches to fallback, try catches to fallback, returns in the middle. Even in the worst form, this is not a bad piece of code. Again, I'm doing these await singles and await single or null provided by Kotlin library. The end result would look like this, DB cached IP, and it just looks like a body. That's the beauty of this. And I would recommend you reading more on Kotlin docs. So, but you can make it suspend all the way. That's the beauty of this. Spring supports suspendable methods all the way down to the bottom. And that's what I'm going to do next. So instead of returning a mono, I made my repository method a suspend. And then I've also extended, instead of reactive CRUD repository, I've got to go on to coroutine CRUD repository. So all the built-in implementations, find by ID and all that, they would be suspended by default. Now my method looks even cleaner and simple. Find by ID, no awaits, find by ID, and upserts, no awaits. Same piece of code. Similarly, at the controller level, I would have the exact same thing. Locate is a suspend function, just like we saw, and everything inside is just a suspend function. So everything all the way to the bottom is a suspend function. So with context is going to give you, the important part is with context here that I called out. With context is just like schedulers. And what it ensures is the pieces of code inside this body are running on a default dispatcher. So remember when you get the handler running the request, it might be on the thread pool that is handling the async IO thread pool that is handling the request. So instead of running on that, I'm running it on default dispatcher. And you didn't see any of the switch to parallels because every time it's coming back, the dispatcher is making sure that we're resuming on this on the default dispatcher or on the worker threads. So dealing with async fragmentation, it almost deals with Kotlin almost deals with it. Here are the bunch of libraries that give you out-of-box extensions for this. So, but what about the legacy calls that are still thread blocking? So, well, in case of mono, you can use bounded elastic and run your code on that. In case of Kotlin, it's pretty simple. You can just do with context. So publish on, so that you control everything in the middle, but with context, it looks like a simple body. there's more to it. I've barely scratched the surface of what Kotlin and Coroutines can do. It has scopes, dispatchers. It does ULET, structured concurrency, flows, channels, actors. Spring Framework 5.2 onwards has full coroutine support with awesome reactor interoperability with coroutines. So most of the stuff would be done out of the box for you. You would be writing pure suspendable coroutine methods. What are the key takeaways? I think when it comes down to a software cycle, especially when you're running and maintaining that, it all comes down to debuggability, readability versus just getting it done. So keeping it simple is the key here that I want to emphasize on. Evaluate your stacks on how you would keep things simple. For further reading, I would recommend a bunch of links here. And thank you, everybody, for your time.
Thanks, Zohaib, for a great example of using reactive systems at scale. Be sure to click the join the discussion link to have to begin the Q&A session with Zohaib happening live. Our next talk will be about getting Spring Boot projects ready for Josh Lung's favorite place on the internet, production. Spring Boot Production Boost is up next at 12:35 Eastern.